Hello, my name is Wil van der Aalst and welcome to this short video where I assume that you have already been playing with tools like ProM and Celonis and you have a basic understanding of how to load the data and also how to do discovery. And now I would like to focus a bit more on conformance checking and also the more advanced capabilities of tools like Celonis. So what I will do is first I will show you, let's say, the new version of Celonis, which is supporting object-centric process mining. What you will see is that we can generate directly follows graphs involving multiple types of objects. We can also discover BPMN models involving multiple objects using the inductive mining algorithm. You can also compute alignments, so you have these very advanced capabilities available. Next to that, I will also show you the basic version of Celonis as is available through the academic alliance license. And I will also show you, let's say, conformance checking in ProM. So let's simply get started. So I already started Celonis. Let's select this space where data is preloaded, but perhaps first I should show the data. So normally you load data through data integration, but in let's say the newer versions of Celonis, you can actually load objects and events. So here the main advantage over, let's say, classical process mining is that you do not need to decide upfront what is exactly the event log that you're going to use. You can simply load all the objects and all the event types into your data model, and then only when you start doing analysis you can pick a particular view. So here I've preloaded data related to procurement and order management, and what you can see is that we have 55 object types, almost 80 event types. And if I, for example, visualize the different object types, there is a graph looking like this, and one can zoom in, and what you now see is that, let's say, these 55 different types of objects. If you are loading a classical event log, you always need to pick a case perspective. That is now not necessary. I can simply load any collection of events and objects. Right, so for example, if so there is vendor invoice. If I, for example, look at something like a purchase order as an object type, then I can click on this, and if I do that, I can see all the different attributes of this type of object. So you can see that there are, let's say, supplying plant, etc., etc. I can also look at the relationships between with other objects. So you can see them highlighted here. You can also see them in the diagram. And we can also see the different event types, or the different types of activities that may involve objects of this type. So you can see, for example, send, purchase, order, update, etc., etc. So this is the view where we are simply looking at object types and events. All the data is loaded there. So if we now go to Studio and I choose this space, then I can, for example, create a new package. Let's call it demo will. Right, and I can here, like we can select the data model, and that is already preloaded, but it's related to the objects and events that I was showing earlier. And for example, I can automatically create a view. If I do that, then we get this canvas, and here we can drag and drop the different elements. So I can, for example, drag a process explorer here, and we are now in the multi-object world. So there may be any number of object types and event types. And here I'm going to select the different object types that I would like to take a look at. For example, we look at delivery and delivery item, and we look at sales order item and sales order. Let me switch this off. So now I've selected 4 object types. I could also select all of them, but then the picture becomes highly confusing. I can also model what kind of interactions we would like to have. So I would like to have a slider in my model. Now I can save it and I can close the edit mode. And now we have generated, let's say, this particular view. And in this particular view, I can, for every object type, so I selected 4 of them, I can select how many different activities or event types you would like to include and the many different connections. So what you now see is that you have this metro map-like visualization where all the stations are corresponding to activities, and activities may involve, let's say, for example, if you look here, then you can see that there are 3 different object types involved in this activity. So you can see all kinds of statistics. So this is the directly follows graph that we have seen before, but now we are looking at multiple objects at the same time, and we basically create the view that we would like to have. So I can also, for example, look at sales orders, right? I can also increase the number of connections, and now you see that here, let's say, new connections are being added. So this is, let's say, if we create a multi-object process explorer, we can also go to Studio, and we can also, for example, create a multi-object BPMN model. So how does this work? We go to the Process Adherence Manager. In the Process Adherence Manager, we need to give it a name. Let's call it PAM will. We need to select the data model variable. There's only one loaded here. There are preset configurations for different process types, but we do not assume that. We start from scratch. And now I'm going to select exactly the same 4 object types that I selected earlier. So I select sales order, I select sales order item, I select delivery and delivery order item. So this is exactly what I also did before. And now, like we can, for example, start by discovering a model. So if I say mine model, there are some configurations here that I can set, and let me, for example, include, let's say, the top 10 variants. So this is like a mining algorithm based on the inductive mining algorithm, considering, let's say, variants and how frequent they are. If I'm happy with this model, I can save and continue. And now I basically freeze the model that I had before, right? So I discovered the model and I kind of fix it in such a way that I can start doing performance analysis and conformance checking. Note that I could also have edited this model. In principle, you can also load models like this. So in the background, the inductive mining algorithm was used to generate this, and you can see that it looks a bit like, again, like a metro map. But what you now can clearly see is that we have concurrency. So for example, this is an AND split, and this is an AND join. And what you can see is that behind the surface, there is a process tree that is converted into a BPMN model. If we look at conformance, we can see that in general it is very good. So for sales order, it's 99.99% of the sales orders are fitting. And here you can see the main deviations that are being discovered. As I said, I would also like to illustrate better, let's say, the conformance checking capabilities. So for example, I can look at the Alignment Explorer. And what I can do is that I can look at the different object types, and per object type, alignments are being computed. So what you see here is that if we look at sales order, we had a very high compliance. As you can see that there are very few deviations, and here we found one. And what you see here is set delivery block occurred too often. Let's zoom in. Right, so we have here set delivery block. It's also highlighted here in this model. And what we see is that this, under view detail, we actually see an alignment. And in alignment terms, set delivery block is a move on log. That means that according to the model, this was not possible yet. And if you look at, we start with create sales order, create sales order header, then we set delivery block, which is here. And after that, we have lots of create sales order items, which are here. Right, so we have a whole sequence of sales order items which are still being created. Then it is approved, and finally, like the delivery block is being set. So here, this one is possible, but the first one is clearly not possible. If we look, for example, at sales order items as an example, we now see that there are more deviations, and if we take a look at the first one, it says create a customer invoice. We can again zoom in here. And so create customer invoice for, let's say, sales order items is something that can only happen, let's say, more or less at the end. And what you see is that this is happening too early, because after this there is still create delivery header and create delivery item, which are, let's say, here before it. So this is showing that in the background we are using alignments. We are also using the inductive mining algorithm to discover these types of things. So hopefully this illustrates a bit that like how these more advanced capabilities work. What we can also do is that we can look at, for example, flow times. So we could look at, for example, we can look at, okay, when was the sales order header created? And we are interested in the throughput time. When was the invoice created, right? And now if we do that, we take, there is a connection between the different object types. So sales order is connected to delivery items. So these are all the items that were in the order, which in the end were delivered. And we look at the first one for sales order, there's only one. And then we look at all the corresponding delivery items, and we look at the last one that is being, the last one for which create customer invoice was being created. And what we now see is that we see, let's say, this time distribution. So this is showing that we can do performance analysis while looking at multiple objects. So this is, let's say, the newest version of Celonis. In the, let's say, academic version, these capabilities are not present yet. So if you are using, let's say, the tool yourself, it probably looks more like this. But I would also like, in the academic version, I would like to show the analysis tool and how conformance checking is being used there. So let's start from scratch. Again, I create a package. Let's call it demo will. Right, and now I add an analysis. And I need to select the data model. So now, so we are not in the case-centric world, so I load the data model that later I will also show to you in ProM. So this is like a simple data set with 1000 orders. So looking at a single object type. If I now generate analysis, then this is, let's say, what you see. And this should be very familiar to you. So we can now start, for example, the Process Explorer. And we can, for example, move up the sliders, and then we see the whole process. Note that all these capabilities. We can look at activity frequencies. We can look at the average throughput time. So this is the view that I assume that you're, let's say, very much familiar with. So this is the Process Explorer. You've also seen things, of course, like, I don't know, creating components. So for example, I can look at the Variant Explorer, right? And then we have this view. And I can now close this. And now we can, for example, look at the top 3 variants, and we can look at the corresponding model that comes under this. But my goal was to get to conformance checking. We have just seen in the more advanced versions that alignments are being used. In the more classic versions of Celonis, let's say token-based replay is being used. So if I go to the conformance checker in the analysis tool, I first need to come up with a model. So I could upload it, I could model it by hand, I could pull it from a repository, but the easiest way is of course to first mine it. So what you see here is that you see the different variants. I can select all of them. Then this is the input used by the inductive mining algorithm. Then I can say launch analysis, and in the background it is creating a model. I click on edit process model, and if I do that, I see the BPMN model that has been generated. So this is the inductive mining algorithm, and the result is visualized as a BPMN model. Note that there is concurrency. So for example, after placing the order, we can send the invoice, and that is concurrent to sending reminders and payment, which are all optional. At the end, we do confirm payment and make delivery, and that is also concurrent. So if we now look at the overview, it is very unsurprising. We have no violations. Everything is fine. So all 10,000 cases are without any problem, and the conformance level is very high. If I now go back to the model, I can now edit it by hand, but what is much easier is I can simply mine it, for example, just for the first two variants. So what we now see is that we are looking at a scenario where people get an invoice and pay, and the scenario where people first get a reminder and then pay, and you can look at let's say the frequencies of that. So with these first two variants, we are already covering half of the cases. Again, I can say launch analysis. So the process model looks like this. So now there is no concurrency, but we have this send reminder, let's say, step that can be skipped. Now we can look at the overview, and now what we can see is that like it's approximately 50-50. These are the half is conforming, half is not conforming. So you can see that the level is fluctuating around 50%. What we can see is that the things that are non-violating are typically, let's say, shorter in time. Doesn't have an effect on the number of steps that are there, and here you can see the main violations. And so there are violations like, for example, send reminder is followed by send reminder, because in our data it was possible that people would get multiple reminders, and this is happening in 25% of the cases. I can also, so there are also other deviations that we find. So for example, we can see that there are, in 7% of the cases, place order is followed by pay. So you can look at these deviations, and you can select any of these deviations, right? And you can inspect them in detail. And you can, for example, zoom into the cases that have this particular violation. And we can look at the Process Explorer, and now we see all the 742 cases that have this particular violation, right? And you can clearly see that, let's say, the problem that we are looking at, that place order was directly followed by pay without invoice or without any reminder, and you can see that that is indeed the case. So hopefully this gives an idea of, let's say, what is possible, let's say, in conformance checking. You can select any violation and then drill down on that. You can also, let's say, whitelist certain problems. So if I go back, let's say, to the overview, I can, for particular things, say that they are not serious, right? And I can add them to the allow list, right? And then they are no longer considered to be a problem, and etc., etc. And so this hopefully shows, let's say, a token-based replay, let's say, in the classical Celonis tool. Although, like, you cannot see the explicit, let's say, number of tokens missing and number of tokens remaining, but this is what is being used in the background. So let's now switch to ProM, and I'm going to load exactly the same data as I just indicated. So that is this log with these 10,000 orders. So I loaded it as a CSV file. I can convert it to an event log. And then we could save it in the XCS format in such a way that we don't have to do that. I only select the end time and I've loaded the data. So what you can see here is that this is exactly the same data as I just showed in Celonis. So what you can see, for example, there are cases where people pay directly after placing an order. We have seen that just now in the Celonis tool. There is also like the possibility to send no reminders or to send multiple reminders. So here you can see the different variants. And now we can, let's say, look at this and also think a bit about what we can do in the context of conformance checking. So now that I've loaded that, I can pick the event log and I can, for example, use the inductive mining algorithm to discover a process model. So here, if I move all the sliders up, what you now see is more or less exactly the same model as that you saw in Celonis earlier. As of course the visualization is a bit different, but again we see it starts with place order, then send invoices concurrent to sending reminders and possibly a payment, and at the end we have, if we pay, then we have the prepare delivery and we can do the make delivery and confirm payment concurrently. So if we look at something like this and we start looking at the deviations here, you can see that there are no deviations, there are no red arcs. However, if I would move down the path slider, right, then you now see these deviations, right? So the red dashed arcs are corresponding to deviations, and I see that because I moved this path slider down. We still have all the activities. And what we can now do is we can look at the individual, let's say, traces. And you can see that some of these traces have, let me make this screen a bit bigger. So what you now can see is that some of these traces have these red, let's say, annotations. And because I kept all activities and I reduced the path slider, what you now see is that sometimes the model says that an activity should happen, but it did not happen in reality. So what you say here is that that there are two activities. So there's one activity that is only in the model and there is one activity that is only in the log. So what you see is that you can look at all the different deviations, and this is not based on token-based replay. This is based on alignments where we can have move on model and we can have move on log. So it's only in the model or it is only in the log. We could also reverse this a bit. So for example, I can filter based on the activities. And now we can again look at, let's say, deviations. And what you now see is that because we remove these activities from the model, they only appear in the log and these diagnostics are being generated. So if you are used to the, let's say, visual inductive miner, perhaps the thing that you do not know is that you can also edit the model, right? So what you see here is a process tree, and I can, for example, remove the concurrent block at the end and make it a sequence, right? And I'm just editing this. So what we now see is that prepare delivery, make delivery, and confirm payment are done in sequence. So you can basically edit the model using this interface. The moment that I start moving the slider again, right, like this changes are erased, and again I have the model that I showed earlier. So at any point in time, so for example, if I move the slider a bit down, we have a model in the background. It is a process tree. It is visualized similar to a BPMN model, and we can export the model as a PetriNet, right? Let's take a look at the PetriNet. What you now see is that we have a PetriNet that was the discovered model as a process tree visualized as a BPMN model mapped onto a Petri net, and I can select an event log and the Petri net, and then I can run all kinds of conformance checking plugins on top of them. So for example, I can do repay a log on Petri net for conformance analysis, and now it is computing alignments. In this window, there is a mapping from the, let's say, names in the model to the names in the log. Like it tries to guess the right correspondence. And what I've done now is that I've discovered, I've replayed the event log on top of the model using alignments, and you can see where the deviations are. As I can look at element statistics here. So what we now see, if we click, for example, on place order, there are no problems. If we click on send invoice, we can see that 742 times there is a move on model only. So these are the situations where people were, let's say, paying before they got an invoice, right? So in that case, the ordering is swapped. We can also click on pay, and then we can see that there are more deviations. So the purple things on the transitions are indicating that there are moves on model. And so something did not happen in the log, but you want it to happen according to the model. If you select the places, what you can see the moves on log. So what you can see in this place, when there was a token in this place, there were over 2,500 times there was a send reminder that was in the log, but was not possible according to the model. And so what you can see here is in the background there are these alignments that are being computed. Every yellow place is corresponding to moves on log. The purple things are corresponding to move on model. Right, and the visualizations that we have is that we can also, so this is the model view, we can also look at the log view, and what you now see is that the green events are synchronous, are good. The purple ones are move on model only, so they are harmful, and there are the yellow parts which is a move on log only. Right, so if we take a look at this trace, and then we see here a move on log only, and here we see a move on model only. And so again here we see the visualization of the different alignments. So hopefully this gives a good idea of, let's say, that in the background ProM and also Celonis are supporting these conformance checking notions. And I hope that this helps to relate, let's say, the theoretical part to the practical part. Token-based replay is very scalable and very easy to understand. At the same time, alignments are the gold standard, and we can see that the more, let's say, mature tools are moving into supporting that type of conformance checking. Thank you very much.